students, welcome to another episode of Vedantu Karnataka Physics. So let's wait for Hi Crazy Boy. Rohan, there's a maths class now. There's no maths class happening now. The maths class is over. So good morning, good evening, students. I hope you're all having a wonderful day. How's your preparation going? Can you all let me know in your chat how your preparation's going? Free Fire Kings. Hello. Hi, everybody. We'll wait for another 1 minute and then we'll start the class. Good evening, Sanjana. Mohammed. I corrected myself. I said good evening, okay? Okay, so today we're, as usual, going to do some important questions. And today we're going to look at the chapter Atoms and Nuclei. Now, why atoms and nuclei? First thing, it's easy. The concepts are not going to fly over your head. You only need to know your formulas. If you know your formulas, you can solve the questions for sure. Another important thing why we're going to do atoms and nuclei is because of its weightage. So I was going through all these past year papers of yours, and I could see in 2024, that is the last year, there were 5 questions from atoms and nuclei. Can you imagine 5 marks just from atoms and nuclei? In the year before that, in 2023, there were also 5 questions. In 2022, there were 6 questions. So there has always been 4 to 6 questions in every year from 2018. Okay, so this is a chapter that you can score, and it's not a very difficult chapter. You only need to know your formulas well. That you have to know. Okay, so that is why we're going to look at atoms and nuclei today. So I want all of you to stay with me for the lesson. So if your friends have not joined yet, send them the link. Let them also join, and then we'll all study together. Quickly share the link to all your friends. Can you all like and subscribe so we can keep doing this? Okay, so let's start. Let's start. So the live chat is running a little slow. So I might not be able to reply to your questions immediately, but I will see them and I will reply to you. Okay? There might be a small lag. Okay, let's start. So atoms and nuclei. Let me take my pen. So this chapter is very important. As I said, for sure you will have 4 to 6 marks. Okay? In some years there were 6 questions, in some years there were 5, some years there were 4, but not less than 4. So for sure you will have 4 to 6 questions. You can easily score 4 to 6 marks. Okay? So all of you grab your pen and paper. Let's solve. First question. In alpha particle scattering experiment, if V is the initial velocity of the particle, V is the initial velocity, then the distance of closest approach is D. If the velocity is doubled, then the distance of closest approach becomes. So what is doubled? V becomes 2V. That's the only thing that's given to you in the question. Now what is closest approach? Closest approach is when you have an alpha particle coming, it hits the nucleus, immediately it bounces back. It's not going to hit the closest it can reach to the nucleus before it bounces back. That is called as closest approach. Okay. Now let's quickly solve this. V is equal to 2V. Now one thing you need to know is when an alpha particle comes, it is moving. Anything that moves has kinetic energy. Okay. So this alpha particle that's moving has kinetic energy. It reaches the nucleus. It gets as closest as it can. It cannot move further. From there it bounces back. So once it reaches there, it is stopped by the nucleus. So at that moment when it is stopped, all of the kinetic energy it had got converted into potential energy, and then it bounces back again with kinetic energy. That's the process that's happening. So Let me write that down. So first thing we will write down kinetic energy. So how much is the kinetic energy? We know that kinetic energy is half m v. Since this is the alpha particle that's coming, kinetic energy of the alpha, half m v alpha square. Okay? Half m v alpha square. Now this is equal to how much? We've also learned that kinetic energy is Ze times 2e divided by 4 pi epsilon naught r naught alpha. Now r naught alpha I am putting it because it is the radius of the alpha. It's just r in the actual formula. So this is the first formula that you need to learn in this chapter. What is kinetic energy? Ze 2e by 4 pi epsilon naught r alpha, r, okay? Because here in the question it's alpha, I have put alpha, but in general r, okay? So you all will take a sheet of paper, keep it next to you, write down the formulas. The first formula is kinetic energy, okay? Now, if I'm equating these two, what will I get? I can see that what I will do is, I'll take this term and I'll take this. I'll take everything else as a constant. Okay? So what I will get is V alpha square is equal to 1 by R naught alpha. Can I do that? If I take everything else as a constant, V alpha square not equal to, you have to put proportionality. That I've explained in all the classes. If you want to replace equal to and put a proportionality, you have to have some constant and then put the proportionality. So I only take V alpha square and R naught. So all the rearrangement is done. Every other term is taken as a constant. Okay. So V alpha square is proportional to 1 by R naught square. So I will use a green pen, because when I send the notes to you, it will be white in color. So I'll cross multiply. R naught alpha is proportional to 1 by V alpha square. Okay. Now what I will do is, I will take the radius of the nucleus of the foil and the radius of the alpha particle, and I will find out the ratio between them. So R naught initial divided by R naught alpha, this will be equal to, it's proportional to 1 by V alpha square. So how will I write this? This will be V alpha square on top divided by V alpha I or initial square. Why did I put V alpha square on top? Because it's 1 by. So when you take the reciprocal, this is what you will get. Now, this is equal to, so what has happened here? Let's read the question. The velocity has doubled. So from the initial, the final velocity is double the value. So if initial is Vi, then final should be 2 times Vi because it has been doubled. So this can be written as 2 V alpha times initial divided by V alpha times initial. There is a square on both the terms. Okay. Now this is what? 2 V alpha square will be 4 V alpha square. V alpha square cancels. So this becomes 2 square, which is 4. This and this will cancel. So now R initial divided by R alpha, which is final, is equal to 4. Now from this I can get R alpha is equal to what? R initial by 4. Now R initial is my distance, is my initial distance. So I will put it as D by 4. This is option D. Is this fine? Ma'am, better if you teach with board and pen in hand. I know, but screen is not visible. The screen, Harni, is the screen visible now? Oh, question is not visible. Okay. Oh, tomorrow your results are coming. All the best, all of you. I hope all of you come out with flying colors. Yes, it's D by 4. For those of you, if the question was not visible, this is the question. Okay. So in an alpha scattering experiment, initial velocity is V and that velocity becomes double. So what you have to do is you just have to take the ratio of both. So ratio of both the distances is equal to ratio of both the velocities. So the velocity of the first one will be this 2 times the velocity of the second. Is this clear? Can you all give me some fire emojis if it's clear to you? Okay. Quickly, students, can you all put some fire emojis in the chat so I also get some energy and we can move on to the next question. Okay, for the next question, if it's not, I hope it's visible to you now. The ratio of area of first excited state to the ground state orbit of hydrogen atom is first excited state to ground state. You have to take the ratio of the area. Now, one thing that you need to know is to solve this, we use the fact that in the Bohr model of hydrogen atom, the radius of the electron orbit in the nth energy level, okay, the radius of the nth orbit according to Bohr is given as Rn is proportional to n square. Okay, according to Bohr. Now, what is area? Area is 4. Area is basically proportional to pi r square. Right. Area is pi r square. So, since r is proportional to n square, area will be proportional to r square. Why? Area is pi r square. Now, if pi is a constant, area will be proportional to r square. And this will be proportional to n raised to 4. Does this make sense to you? Okay. Since area is pi r square, if you take pi and equal to, change it with a proportionality, it becomes a proportional to r square. Now, since r is proportional to n square, r square is proportional to n raised to 4. Now, what we have to do is we have to take the ratio of a2 by a1. The first excited state to ground state, the ratio of area for the first excited state and the ground state. So, first excited state to ground state. So, what will the states be? The states will be n equals 1 and n equals 2. First excited state and the ground state. So, it would be, and area is proportional to r square. So, this will be equal to n1 by, sorry, okay. So, area of first excited state divided by area of n2 will be equal to n1 by n2 raised to 4 because area is proportional to n raised to 4. This is equal to how much? n1 is how much? 2 into n because it is a first excited state divided by n raised to 4, which is 2 raised to 4, which is equal to 16. So, an1 is to an2 is equal to 16 is to 1. Why 16 is to 1? Because it is 16 by 1. Okay. Why did I take 2n by n? Because the ground state I'll just take it as n. And the excited state I'll take it as 2n. So I can cancel the terms off. You can just take it as 1 also. It won't make a difference. 2 into 1 divided by 1. It's the same. And you can take it as 1 as well. No issues. Is this clear to you? Vaibhav is fully scared for tomorrow. You don't have to be scared. That's going to be a reality. You have to face it. So face it with courage. Whatever happens, it's all right. Okay? This is not going to be a big deal. Okay. So, yes. Let's move on to the next question. Yeah, yes, Pratnya, it's 16 is to 1. It's 16 is to 1 because it's 16 divided by 1. Okay, can you all give me some thumbs up if you've understood this much? Quickly, quickly. Can you have some thumbs up? All those who are scared for tomorrow, can you put some fire emojis in the chat? Mhm. You're welcome, Vaibhav. See, you don't have to be scared, kids. It's just an exam, okay? You have to take it in that spirit. Whatever happens, you face it. You don't have to be sad or depressed. If it's not that great, you try. When you get into college, you work hard there. There's always another chance. Okay? You don't have to be depressed or sad or no, this is not the end of your life. Those who are doing well, very good as well. Okay, let's go to the next question. Is everybody sleeping in class? Can I have some emojis? Can I have some fire in the chat? Yes, Vishal. All the best to you as well. Okay, let's move on to the next question. The ratio of volume of AL aluminium 27 nucleus to its surface area is given by R naught equals 1.2 into 10 raised to minus 50. Students, this chapter you will definitely have 4 to 6 questions, and this is a chapter that all of you can answer. Because the only thing you need to know is formulas that I'll teach you today. So pay attention. Don't waste your time today, okay? Results will anyways come tomorrow. You don't have to bother. Let's finish. Let's learn. So we have to find out the ratio of volume to surface area. So the previous question was surface area by surface area. Here it is volume by surface area. So you have to find out the ratio of V by I. Sorry, A. Volume divided by area. So V by A is what you have to find out. Now what is volume? 4 by 3 pi r cube. We've all learned this in school. 4 by 3 pi r cube. And area will be 4 pi r square. Okay. So the ratio of volume to area would be 4 by 3 pi r cube divided by 4 pi r square. It's not a circle, it's a sphere. That's why 4 pi r square. Now cancelling all the common terms, what remains? 4 pi r cube r square cancel. So you get r by 3. R by 3 is what? Remains. Now, you might have learned, okay, this is the next formula that you need to learn in this chapter. R is equal to R naught A raised to 1 by 3. Okay, so R naught is a constant. You have to know the value of R naught. I mean, it's given to you in the question, but it's always good to learn it because in some questions it will not be given. R naught is a constant. R is the radius. And what is A? 27. It's given to you in the question. AL 27. So A is 27. Now, what shall we do? R is equal to R naught A raised to 1 by 3. So what is R? R is equal to 1.2 into 10 raised to minus 15, which is your R naught, is given to you in the question, into how much? A raised to 1 by 3. A is 27. 27 raised to 1 by 3. Praknya is very fast. I am slower. Now, how much is 27 raised to 1 by 3? It is 3. So, R is, if you do the math, you will get 3.6 into 10 raised to minus 15 meters. Okay. Now what is my formula? The ratio V by A is R by 3. So 3.6 into 10 raised to minus 15 meters by 3, which is 1.2 into 10 raised to minus 15 meters. 3.6 by 3. 3 cancels. 3 and 6 2. 1.2. So the answer is option D. Yes, Sanjana, Pragnya is D. Very good. See, it's a very simple question. So these are questions that came in the 2024 KCET. Okay. So here the formula that you need to know is R equals R naught A raised to 1 by 3. Okay. Okay. So this is the formula that is used to find out the radius. R naught is a constant. A is the number that's given to you. AL 27. Is this clear? Shall we move on to the next question? Free Fire Kings is crying. Why are you crying, Free Fire Kings? Is that a crying emoji? What is that? I don't understand all your new generation stuff. I think I'm a little too old. Okay, let's move on to the next question. This is also a question that came in 2024 KCET. Consider the nuclear fission reaction. Okay, so this is a reaction. One neutron goes and hits a uranium. It breaks up into barium, krypton, and it emits 3 more neutrons. That's the equation here. Assume all the kinetic energy is carried away by the fast neutrons only, and total binding energy of uranium, barium, krypton are these values. Calculate the average kinetic energy carried away by fast moving neutron. Okay, so the question is, there's a fission reaction. This uranium, neutron hits the uranium. It breaks into barium, krypton, and 3 more neutrons. Okay, so the individual energies of the uranium first, then it splits into barium, krypton, these 2. So all these 3 individual energies are given. But shouldn't all the energy of uranium be divided to the energies of barium and krypton? But it is not. Some of it is lost to the neutrons. So we will find out what happens. Okay. This is also a very simple question. So first thing, what are the energies given? So the binding energy of uranium is 1800. MeV is there. I'm not writing it. It's the unit MeV. Next is the binding energy of barium. Barium is 1200 MeV. Next is the binding energy of, what is it? Krypton. Krypton is 7008 MeV. All these 3 are given to you. Now, the binding energy of the reactants, right? Total binding energy of all 3, 1800. So the binding energy of the reactants, which is uranium, is 1800. Binding energy 2, I will put it as the binding energy of the products, is how much? 7200 plus 780. Sorry, 1200. 1200. So the reactant is uranium. Product is krypton and barium. So 1200 plus 780, 1980 MeV. So when you subtract, there is something lost. So the question is, average energy is how much? 1980 minus 1800 divided by how many components are there? 3. Uranium, barium, krypton. So 3. So this will give you 60 MeV. Okay? Yes, Pragnya, it's 60. Very good. Is this clear? Can I have some fire emojis in the chat? Pragnya is the only person who's answering. So Sanjana also, I think Sanjana stopped answering. Where is Sanjana? Yeah, Sanjana is there. Sanjana also answered. Where are the others? Can I have some more answers? This is a very easy chapter. For sure you'll get some marks. At least 4 to 6 marks. I won't say 5. Maybe 4, maybe 6, maybe 5. I don't want to give you false hope. Thank you, Om, for that fire. Can you others also put some fire emojis in the chat? Quickly. Let's move on to the next question. Okay, so the next question is the natural logarithmic activity R. Okay, you might not be able to read the question, no? Okay, the natural logarithmic activity R of a radioactive sample varies with time as shown. Blah blah blah. Now there are N0 undecayed nuclei. Okay, so initially what happens? Initially it's all radioactive, and then slowly they start decaying. That's what happens in radioactivity. So initially nobody has decayed. Everything is radioactive. Everything is unstable. Okay, and this is the graph. So I don't know if this graph is clear to you. I just hope it is. So this is the initial point. So at time 0, you have 2 as the activity. ln R is 2. Okay. So at time t equals 0, you can see ln R is equal to 2. ln R0. Since its time is 0, I put it as R0. ln R0 is 2. This is the first thing that you get from the graph. Now what I will do, to remove the ln, I take it as exponential. So R0 is basically exponential of 2. And what is e raised to 2? E raised to 2 is 7.5. It's much clear. This much data I have from my graph. At 0, ln R. Why ln R is 2? Because on the y-axis it's ln R. Okay. So this much I have. Now another formula that you need to know in this chapter. Write it down all of you in the equation sheet. R0 is equal to lambda n0. This is the formula that shows activity. Okay. Now lambda is how much? Lambda is basically the slope of the graph. How will you get the slope of the graph? Slope of the graph is taken by y coordinates divided by x coordinates. So let me take this set. So what is the y coordinate? Y coordinate is 1. X coordinate is 10 into 10 raised to 3, because here is 10 raised to 3 seconds. This is basically slope. Okay. So yeah, so this becomes 10 raised to minus 4 seconds. Now I have R0, I have lambda. Quickly find out N0. What's the big deal? Very easy. N0 is R0 by lambda. How much was R0? 7.5 divided by 10 raised to minus 4, which is 75123. Let's see if that option is there. Yes, Praknya, I zoomed in. That's why you were not able to see the options. But your answer is there. It's correct. It's option C. Okay. So for those of you who you were not able to see because of my head, I will just move. Is this clear? So another equation for your equation sheet. R0 equals lambda n0. This is when you have half-life, radioactivity and all that. When something related to radioactivity comes and they ask you to find out the quantity or how much is there after a certain amount of time, R0 equals lambda n0. Okay. Let's move on to the next question. Yes, ohm, it is 75,000. Very good. Yeah, here I just put this formula. This, when I share this, you can go through this. For those of you who are wondering how R0 is lambda n0. Okay, this is for time t. This is from the formula dn by dt equals minus lambda n. Okay, so first order kinetics for radioactive decay. You don't have to get worried looking at all of these. You only need to know the formulas. Okay, so the rate of decay, this is also another formula that's important. The rate of decay is equal to lambda n naught e raised to minus lambda n. Alright. Okay, Sneha, Priyanka, you've all given me a thumbs up, so I think it's clear. So this is not the solution, okay? This is just a formula, how it came, for those of you who are curious enough to know that. I mean, you might have definitely learned this in your second POC, but even if there's one person who's not who doesn't remember that, that is for you. Okay. This is deleted. Half-life is not there. Kavindram. Okay, then I'll check that and get back to you. So what I'm actually doing in class is all past year questions. Okay, I usually cross verify, but I'm a human. I can make mistakes. So please forgive me if that's there. Next question. But I have to make sure I will verify and I'll get back to you. In the Rutherford's alpha scattering experiment, as the impact parameter increases, the scattering angle of alpha particle, what happens to the scattering angle of the alpha particle is the question. So here what is the question formula for impact factor? B is equal to 1 by another formula that you need to know. 1 by 4 pi epsilon naught ZE square cot theta by 2 the whole divided by kinetic energy half mv square. That is your kinetic energy. Okay. Write down on your formula sheet another formula that you need to know. So taking everything constant, I will write B is proportional to cot theta by 2. I'll take everything else as a constant. So what happens? The impact parameter B will increase when cot theta by 2 increases. That is what direct proportionality means. When one increases, the other has to increase. But for cot theta by 2 to increase, the only possibility is when the angle decreases. So only if theta decreases, cot theta by 2 can increase. So the answer will be decreases. Okay. Is this clear? Can we move on to the next question? So this is another equation for your equation sheet. If the question is related to impact parameter and scattering angle, this is the formula that you should use. Okay, can I have some emojis? Can I have a thumbs up or a fire? Or can you go like the video if you understood this much? Let's move on to the next question. Okay, 3 energy levels of hydrogen atom and the corresponding wavelength of the emitted radiation due to different electron transitions are as shown. Okay, so you can see this is E3, this is E2, this is E1. Now, where is the first transition from E2 to E1? This transition is called lambda 1. Now, from E3 to E1, the transition is called lambda 2. Now, E3 to E2, the transition is called lambda 3. Now, I will write down all of these transitions. I'll first erase this. Let me not make a good diagram 30. I'm very bad at drawing, okay? And you might have seen I'm very bad at writing as well. I'm trying to improve it. So, yes. So, I will write down everything. First thing I will do, lambda 1. What is lambda 1? E2 minus E1 because the transition is from E2 level to E1. So, E2 minus E1 is what? Hc by lambda 1 is equal to Hc by lambda. That's the formula that I'm using. Change in energy is Hc by lambda. Next transition, E3 to E1. So, E3 minus E1 is equal to Hc by lambda 2. Next transition, E3 minus E2 is equal to Hc by lambda 3. Okay. So here I've written it as lambda, but I said C. So this is C. Now what I'll do is I'll name this A, B, and C. Now all my options are in terms of, okay, all 3. So let's not look at the options now. Let's solve it first. Now, if I subtract what all, I can get something nice, something useful. So if you think, you can actually subtract A and C. You can actually add them. Let's add them. Adding A and C. What happens? E2 minus E1 plus E3 minus E2. So E2 cancels. It becomes E3 minus E1 E3 minus E1, how much would it be? Hc by lambda 1 plus Hc by lambda 3. Now what is E3 minus E1? It's your equation B, Hc by lambda 2. So instead of E3 minus E1, I'll substitute it as Hc by lambda 2. Hc by lambda 2 is equal to Hc by lambda 1 plus Hc by lambda 3. All the Hc's are the same, so cancelling all of them. 1 by lambda 2 is equal to 1 by lambda 1 plus 1 by lambda 3. This is 3, okay? 1 by lambda 3. Now from this, lambda 2 is equal to lambda 1 lambda 3 by lambda 1 plus lambda 3. That is going to be option D. Okay? Yes. Is it C? You're all getting C. How are you getting C? Yeah, yes, Pragnya, it's option B. This is also a very simple question, right? You might be saying in your mind, everything is, ma'am, saying everything is simple. This is all very difficult also, no? This is not difficult, students. If you practice, it will be all easy. You only need to know formulas and where to apply it. You have to understand where the formula comes from. Ram Charan, you got B. How did you get B? Lambda 1 in terms of lambda 2 and lambda 3. No, it wouldn't be plus. It would be minus if you take it lambda 1. It wouldn't be B. Is this fine? Shall we move on to the next question? Okay. C. You should get D. If you have any doubts, you can ask me in the chat. Otherwise, you should all give me some fire emojis. Put some fire or some thumbs up in the chat. One trick for remembering formulas. Yeah, I will do a video on tricks to remember formulas. One main trick is write and study. There's something called as muscle memory. So even if your mind forgets, if you've written it so many times, you remember. See, this formula is very easy. E equals hc by lambda. It's a very simple formula, no? Okay, let's move on to the next question. A radioactive sample has half-life of 3 years. What does that mean? A sample has a half-life of 3 years. That means if the sample has 50 radioactive nucleuses, after 3 years, it will become 25. That is a half-life. If it has 100, after 3 years, it will become 50. So, 50 of them will not be radioactive anymore. Only 50 radioactive will remain. Okay? 100 were radioactive. After 3 years, only 50 are radioactive. The others are all normal now. That is half-life. Okay? The time required for the activity of the sample to reduce to 1 by 5 of its initial value. Okay? Half-life is 1 by 2. We have to find out the time required for 1 by 5. So, let's write down whatever is given. The half-life is 3 years. And I already showed you formula. There, one formula was R is equal to R naught e raised to minus lambda t. Now, how much would your R be? R should be R naught by 5. Because it is for 1. You have to find out the time it takes for the activity to become 1 by 5. Okay. Other than that, lambda is also equal to ln 2 by t half. Okay, so this is how the decay constant is related to half-life. Something you also need to know. So decay constant is equal to ln 2 by t half. So depending on your t half, this value will change. How much is ln 2? Ln 2 is 0.693. One value you should remember. Ln 2 is 0.693. Half-life is 3. So this is approximately equal to 6393. See, these are all numbers you can easily cancel. So 3 and 6 cancels. 0.3 and 6 cancels. It's 2. 3 and 9 cancels. It's 3. 3 and 3 cancels. It's 1. So lambda is 0.231. 1. Now let's get back here. So R naught by 5 is equal to R naught e raised to minus lambda t. R naught cancels. 1 by 5 is equal to e raised to minus lambda t. So I will remove the exponential part. So I will get ln 5 by how much? How much is your lambda? 0.231. 0.231. This is approximately equal to 7 years if you do the math. So it is B. Yes, students, so many of you have got the answer. Very good, very good. It is B. Okay. So I will write the step here for those of you who have not understood this much. So ln 1 by 5 is equal to e raised to minus lambda t. So that cancels. There's a minus sign here and there's a reciprocal there. So this becomes ln 5 is equal to lambda t. So t is equal to ln 5 by lambda is equal to. Okay, and this lambda we already calculated. That's what happened here. So for those of you who didn't understand that part in between. Okay. Is this fine? Can you all put some thumbs up if this is fine? And I want all of you to go like the video as well, because only if you like and subscribe, we can keep moving forward. The channel needs your help as well. Like we help you, you have to help us. This is like a give and take. Yeah. So let's move on to the next question. What is happening? Yeah, I know, Vaishnavi, that tomorrow is your result. Okay. The whole of radioactivity is deleted. Alright, so then we'll move on to the next question. What about the decays? That's there, no? So, in the following equation representing beta decay, the number of neutrons in the nucleus X is this much. Okay. So, what is the beta decay reaction is given to you. So, what is the answer here? 210 minus, what would it be? It would be 210 minus 84, which is 126. Okay. How did I do this? So what happens in beta decay? In beta decay, one neutron gets converted into a proton and an electron. Okay. So that is why 83 protons become 84 protons, because a neutron got converted into a proton. So it becomes 84. So X will have the numbers 210 and 84. So when you subtract them, you will get that number. So it's going to be 126. Why are you crying, Manya? Your results will come. There's nothing you can do about it. Relax. Okay? Whatever your results are, you don't have to worry. There's always another thing that you can do. We'll figure it out. Okay? You don't have to sit and cry. Alright? So students, you don't have to worry so much. This is just one part of your life. You still have a huge life in front of you. You have so many more things to do. So even if this one part, if it's good, well and good. If it's not good, you still have options in your life. Okay? Yeah. Please don't be so worried about your results. Yes, Nisha. Yes. Okay, next question. A nucleus with mass number 220 initially at rest emits an alpha particle. If Q value of reaction is 5.5 MeV, calculate the value of kinetic energy of alpha particle. Okay, now what is Q value? Q value is basically kinetic energy of alpha plus kinetic energy of your particle. So let me just write that. Q is equal to you have to start your preparation tomorrow. You can start watching all the series. So in this channel, you have all subjects, questions, sit and solve. Practice questions. So kinetic energy of alpha plus kinetic energy of X. Okay. So the nucleus, what nucleus is not mentioned. So I'll just put it as X. So this is your total Q. Okay. Now what's the formula? I mean the equation. So there is some nucleus, let's name it Y. It has a mass number 220. So this Y disintegrates, it becomes some X, and it also emits an alpha. So if it emits an alpha, this will become 4 and 2. So obviously 220 minus 4, this should be 260. Okay, because it's alpha, you know that. Now, we also know that linear momentum is conserved here. Okay, so when linear momentum is conserved, what is it? mv, linear momentum is mv. So mv for x should be equal to mv for alpha. So m alpha v alpha should be equal to mx times vx. So from this, vx is equal to what all? M alpha v alpha divided by mx. Okay, now this Vx, I will go substitute it in the formula for kinetic energy. Okay, let me go substitute it for kinetic energy. Where is it? Y 220, sorry, kinetic energy. Kinetic energy is half mv square. So half m alpha v alpha square is equal to, sorry, plus half mx vx square. So m's are all capital, okay? So here also it is capital. Half mv, all that is fine. Now q is given to you. The value of q is given in the question. It's 5. So 5 is going to be equal to half m alpha v alpha square plus half, instead of vx, I will write it as m alpha v alpha by mx, because vx, I already found out a value for vx. So mx and mx together becomes mx square. Sorry, m alpha and m alpha together becomes m alpha square. So mx vx square, instead of mx, I will write, instead of vx, I'll write it as half m alpha square v alpha square divided by mx. Why only mx? Why mx is not square? Mx and mx cancels. Mx square and mx cancels. So only one mx remains. Okay. Now I will do the math. So this is 5.5. So 5.5 is equal to half m alpha v alpha square times 1 plus m alpha by mx, taking out all the common terms, m alpha by mx. So this is 5.5. Half mv square is kinetic energy. So kinetic energy square times 1 plus m alpha is how much? How many particles are there in the alpha? 4. How many particles are there in the x? 216. So 4 by 216. So what does it become? This is not square, okay, it's alpha. So it would be Ke alpha would be 5.5 divided by this. If you do the math, you will get 5.4 MeV. quickly do the math and see if you're getting option B. So 2 things you need to know here. Momentum is conserved and Q is kinetic energy of the nucleus plus kinetic energy of the alpha. This is clear to all of you? So Q is basically total kinetic energy plus total kinetic energy of X. Can we move on to the next question? Okay. Question 11. The radius of hydrogen atom in the ground state is 0.53 angstrom. After collision with an electron, it is found to have a radius of 2.12 angstrom. The principal quantum number n of the final state of the atom is. So the question is to find out this principal quantum number of the final state. Radioactive decay is a continuous process. Once it starts, it never stops. For it to stop, all the nucleuses have to finish, emitting. So they have to become stable. So it's a continuous process. Okay, let's write down whatever is given. So R1 is given. R1 is 0.53 angstrom. N1 is the first one. So N1 is 1. And R2 is 2.12 angstrom. And we also know R is proportional to M square. We've done this. R is proportional to N square. We've already learned this formula. So let's take the ratio. R1 by R2 will be equal to N1 by N2 square. And this would be 0.53 by 2.12. And this is going to be N1 is 1. So 1 by N2 square. Because N1 is 1. Okay. So what is 1 by N2 square? It's basically 1 by 4 square. So this is basically 1 by 2 the whole square. This is not 1 by 4 square, it's just 1 by 4. So this is basically N2 is equal to 2. Why is N2 2? Because N2 square is 4. So it's option C. Yes, very good. Shahid, Priyanka, yes, all of you. N square is 4. N is 2. Okay. This is fine. Let's move on to the next question. Question number 12. In accordance with the Bohr's model, the quantum number that okay. In accordance with the Bohr's model, the quantum number that characterizes the Earth's revolution around the Sun in an orbit of radius this much and speed this much and mass this much. You have to find out the quantum number. It's very easy. So this is your V. This is R. And this is ME. Now, according to the Bohr's model, we know that MVR is equal to NH by 2 pi. What is H? H is the Planck's constant, 6.62 into 10 raised to minus 34. Okay. And N would be what? N would be 2 pi MVR by H. Substitute 2 into 3.14 into 6 into 10 raised to 24 times 3 into 10 raised to 24 times 1.5 into 10 raised to 11, the whole divided by 6.62 into 10 raised to minus 34. So when you do the math, take the powers separately, take the numbers separately. You will get 2.57 into 10 raised to 24 plus 24 minus 34. 24 plus 24 plus 11 plus 34. 34 will go to the numerator. So it will be 74. Which option is that? 74. It's option C. Okay. Let's move on to the next question. Is this clear? If it's clear, can you all put some fire emojis in the chat? So this is another formula that you need to know. MVR is equal to NH by 2 pi. Yes, Pragnya, it's option C. Okay, question 30. So Bohr's radius is given, and again same formula, R is proportional to N square. So R1 by R2 will be equal to N1 by N2 the whole square. Now R1 by R2 will be equal to the first radius and the third radius. So N1 is 1, N2 is 3. It's given to you in the question, the radius of the third orbit. Square, which is 1 by 9. So R2 will be equal to, since it's 1 by 9 R1, it will be equal to 9 times R1, which is 9 into 0.529529, which is 4.761 angstrom. 0.529. So which option is this? 4.761 angstrom. Yes. Okay. It's option B. Are you all getting option B? Okay. Now we'll just have a break for 5 minutes. Resume back at 9:03. Yes, students, it is option B. Okay, just give me some time, just drink some water and come. Okay, students, welcome back. Let's continue. Okay, question. Binding energy of a nitrogen nucleus N147 given M N147 equals 14.00307 whatever blah 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 U. Yeah, you have to find out the binding energy. So the mass is given to you as 14.00307 U. Did you all leave? Are you back? I'm back. It's 9:03. Please come back. Okay. Now, things that you need to know. First thing, mass of proton. How much is mass of proton? 1.00783 AMU. And then what else? Mass of neutron. Mass of neutron is how much? 1.0087 AMU. Now, in nitrogen, how many protons, how many neutrons? 7 protons, 7 neutrons. So, the total mass, delta M, will be 7 protons, the mass of 7 protons plus the mass of 7 neutrons minus the mass of the whole nitrogen. So, how much would that be? 7 into this one, 7 into 1.00783 plus 7 into 1.0087 minus 14.0037. So that would be approximately 0.1124 excuse me students 243 AMU. Now binding energy is what? E is equal to mc square, E is equal to delta mc square. Now since this is in AMU instead of c square, you can just write it as 931 to convert it into mega electron volts. So 0.11 into 931, how much is it? It would be 104.7 MeV. E is equal to, yeah. So it is option D. Yes, Kavin Ram. It is option D. Very good. Good. Good, good, good. All of you doing well? Can I have some fire emojis in the chat? Okay. Yes. So 1 AMU is approximately equal to 931 MeV. That's why instead of C square, I take it as 931. Now, which of the following radiation is deflected by an electric field? This is not a mathematical question, it's a conceptual question. So, what is deflected by an electric field? Let's first look. Neutrons will definitely not be deflected because it is made out of neutral charges. Neutral and a field does not have to deflect. Gamma rays, what are gamma rays? Gamma rays are just high energy particles. So, energy is not going to be deflected by electric field. Next is alpha. Alpha is a positive charged nucleus. So it can be deflected by an electric field. Now what about X-ray? X-ray is also an electromagnetic ray. It does not have to be deflected. So what is the answer? Yes, it is alpha particles because alpha particles are deflected by both magnetic and electric field because they have a charge. They are positive. Is that fine? Are you okay? Those who've understood this, can you put some fire emojis in the chat? I'm telling too much fire emojis, no? Am I irritating you? Then you can put emojis of your choice. Okay? So if you've understood till now, comment that you've understood. Next, a nuclear reactor delivers a power of 10 raised to 9 watt. The amount of fuel consumed by the reactor in 1 hour is. So, power is given to you. Power is 10 raised to 9 watts. C is the speed of light. T is time. Why do I need all this? Because the only formula that I know right now that I can use is P is equal to E by 2. And we already learned the formula E is hc by lambda, but I can't use that here. So I know another formula E equals mc square, that also we have used. So I will write that mc square by T. Okay. Now m would be what? Power into time by c square. So what is power? 10 raised to 9. Time is 1 hour, 60 into 60 seconds, 3 into 10 raised to 8 square. Quickly doing the math, 10 raised to 9 into 3600 divided by 9 into 10 raised to 16 will be, I think it would be 4 into 10 raised to minus 5 kilograms. But in the option it's not there. So let's make it 4, 0. Okay, we can write it as, the answer is in grams, right? So let's write it as 0.04 into 10 raised to minus 3 kilograms. So this is basically 0.04 by 1000. So it would be 0.04 grams. Option B. Okay. Yes, Deepa, you've understood. Is that the yes meaning of the yes? Yes, very good. B. Yeah. Okay. Let's move on to the next question. Energy of an electron in the second orbit of hydrogen atom is E2. Okay. So the second orbit has an energy E2. The energy of electron in the third orbit of helium. Okay. So it's the second orbit of hydrogen and third orbit of helium. We have to find out the energy in the third orbit of helium. Let's quickly solve it. So another formula in the chapter. You can all know that onto your equation sheets. En is equal to minus 13.6 z square by n square. So I can also say En is proportional to z square by n square if I take 13.6 to become a constant. Now for hydrogen, everybody knows z is 1. So what is En? En is proportional to 1 by n square. And for the second orbit, En is proportional to 1 by 2 square, which is 1 by 4. This is for hydrogen. Now for helium. For helium, Z is equal to 2 because He2 plus, and we have to find out the energy of the third orbit. So N is equal to 3. So let's do the proportionality. So En would be proportional to 2 by 3 square. So 2 square by 3 square. Now, so E of the second orbit, which is hydrogen, divided by E of the third orbit, which is helium, is going to be equal to E2 is 1 by 4. 1 by 4 divided by 4 by 9. So I will just write it as into 9 by 4. 4 4s are 16. So 9 by 16. So let's write down the ratio. So E3 would be equal to 16 by 9 E2. Let's see if that is there in the option or we've gone wrong. 16 by 9 E2 is there. Option B. You all get this? Option A. How are you getting option A? It's option B. Haha. Okay, you might have taken it as the other way around. So if you multiply E3 here, you will get E2 equals 9 by 16. But you have to be careful. That's not there in the option. So it's option B. Okay. So it depends on how you're taking the ratio. E2 by E3 equals 9 by 16. So E3 is 16 by 9 E2. But E2 is 9 by 16 E3. But 9 by 16 E3 is not there. Look at option A. It's 9 by 16 E2. That is wrong. So it is obviously option B. Okay. Let's move on. Okay. Next question. An electron In an excited state of lithium, Li2 plus ion has angular momentum 3 pi by 2h. Perfect. The de Broglie wavelength of electron in this state is p pi a naught. We have to find out the value of p. Okay, so we have to find out the value of p. So de Broglie wavelength, what are the things that we know? We know that L can exist only, angular momentum is nh by 2 pi, and it's given to you as, in the question it's given as 3h by 2 pi. So basic logic, so what would n be? N would be 3. This much is clear. Now wavelength lambda is h by p, which is what? H by mass into velocity. Now I will just multiply r on top and at the bottom. Okay, since I'm doing it on the top and the bottom, it will cancel out. But why am I doing that? Because I will show you what I can do with this. What can I do with this? So this is the same as HR divided by, what is MVR? My angular momentum. So according to de Broglie, let me not write this one here. This is going to be equal to MVR as well. Okay. So instead of MVR, I will write 3h by 2 pi. So h I will cancel. What would it become? It would become 2 by 3 pi into r. Okay. Now let's look at the question. For Li2 plus atom, the radius is a naught. It's given to you in the question. A naught equals Bohr radius. So the radius is a naught. Now what is the formula? R is equal to R naught n square by z. N square by z, which is equal to a naught. N is what? 3 square. We already found that out. And z is what? Again 3, because it's a lithium. So this is basically 3 a naught. Okay. Now lambda is equal to 2 by 3 5 times a naught into 3, because it's instead of r I will put it as 3 a naught. So 3 and 3 will cancel. It become 2 pi a naught, which is similar to p pi a naught. So p is equal to 2. So which option is that? It is option B. Is this clear to you? Okay. So r equals r naught n square by z. This is for the radius of the orbit. Is this clear to all of you? So from the question we have angular momentum, and angular momentum is MVR. We also know lambda equals h by p. Yes, very good. B. Okay, let's quickly move on to the next lesson. Next topic. Question. What am I saying? Next question. Okay. So in a nuclear reactor, heavy nuclei is not used as moderator because they will break up. Electric collision of neutrons with heavy nucleus will not slow them down. So first you need to know why moderators are used. Why are moderators used? Moderators are used to slow the nucleus. It is to slow down everything. But if you use a heavy nuclei, it will not be slowed down. So obviously the option would be B. Heavy nucleus are not used as moderators because they do not efficiently slow down the neutrons. Heavy nucleuses usually absorb neutrons. They don't slow them down. So it would be B. So usually you have these light elements like hydrogen or deuterium or carbon. They're all used to maximize the moderation. Okay? Is this there? So all of you still with me, good job. You are doing a good job. Okay? Let's move on to the next question. Yes, can I have something in the chat? Can you all write something in the chat? How are you all? If you're fine, write fine in the chat. Let's have some conversation. If you're all fine, write fine in the chat. Okay, next question. The period of revolution of an electron revolving in the nth orbit of hydrogen atom is proportional to. Okay, so let's see. Another equation is time period. Did you tell me to have water? I just had water. Thank you so much. If you have asked me, okay. So another equation you need to know in this chapter. Time period is Priyanka's fine. Good, Priyanka. Singer is fine. Singer, do you actually sing? Hmm? Yeah, all of you have already answered C. Good job. It is C. So the formula is 2 pi Rn by Vn. Now when I substitute it, I will get 4. Yes, all of you got 1 mark for this. You all answered C quickly. So for those of you wondering how C, ma'am, what did you do? I will do it now. Divided by m e raised to 4 n cube by z square. So I will take everything else as a constant. So I will get t proportional to n cube. So it will be n cube. You have to know your formulas to know this. And yes, 2 pi r by v. I just put it as n because I don't know which orbit. So I will just put it as Rn by Vn. Okay, singer, you're a singer. Good. No, it's a very wonderful talent. Okay, question 22. Angular momentum of an electron in hydrogen atom is 3h by 2 pi. Find out the kinetic energy. Let's do it. So, angular momentum nh by 2 pi is 3h by 2 pi. So, again we know n equals 3. Okay. Now, what is kinetic energy? Note down this formula. It would be energy is basically 13.6 z square by n square. So put n as 3, simple. So 13.6 z square, z is 1, right? Yeah, hydrogen atom, so it's 1. N is 3. So 13.6 by 3 square. You will get 1.51 eV. Simple question. Energy is 13.6 z square by n square. So which option is that? Option B. Option C. Why, Deepa? Why are you not fine? Is it because your results are coming tomorrow? You're all, after tomorrow, you will be fine. Because I know you'll all do well. Yes, singer, it's B. Okay, let's look at the next question. It might not be clear to you. Sorry for that. So, just look at the figure. There are some alpha particles that are moving. So, A is moving fast, B is deflected backwards, C is deflected slightly. So, which one will be the most? Obviously A, because according to the alpha scattering experiment, most of the atom is empty. So, obviously A has to be maximum. Let's see where A is maximum. A is maximum here. A is maximum and C is minimum. Yes. A is not maximum anywhere else, so it should be option B. Because most of the atom is empty. It's already proved. See, what I'm doing in class is all the previous year papers. Questions. These are all questions that appeared in previous years. So these are the things that you can practice. That's why I'm doing these in class. Okay. Mock test is official website is tougher than original paper. Yeah, it's always like that. Mock tests are always difficult. So hopefully the main exam will be easier. Let's just hope so because we can't predict on anything like that. Okay. So next question. Two protons are kept at a separation 10 nanometers. Let Fn and Fe the nuclear force and the electromagnetic force between them. Okay. Session PDF. The session is not over. Let the session finish and then I'll give you the session PDF. Okay. You only want session PDF, don't want session. I saw, Neela. Okay. So, two protons are kept at 10 nanometer apart. So, what is the answer to this? Can you quickly tell me in the chat? So, one thing you need to know, nuclear forces are for particles that are very close. They're short range forces. So, this is 10 nanometers. So, nuclear forces are definitely in the range of ferrometers, which is very small. So, this is definitely going to be for electromagnetic force. So, if they're kept at a separation of 10 nanometers, the force is going to be electromagnetic. So, electromagnetic force is going to be greater than nuclear force because the effect of nuclear force is for very small distances. See, imagine nuclear force is inside the nucleus, which is where the protons are very close. So it is a short range force of the order of few ferrometers. Is that clear? So it's B. Nobody answered B. How is it going to be A? Because the separation is quite large. It's 10 nanometers. Compared to the size of the nucleus, this is large. Is that clear? Can you all put some fire emojis in the chat if that's clear? Next question. During a beta decay, what happens? A. It's not A. Okay. So during a beta decay, what happens? An electron is ejected. An atomic electron is ejected. Is it really an atomic electron? I don't think so. An electron which is already present in the nucleus is ejected. Come on, there are no electrons in the nucleus. In the nucleus, there are only protons and neutrons. Then how can an electron be emitted from a nucleus? So definitely not option B. Option C. A neutron in the nucleus decays emitting an electron. That's possible. So it's forming an electron. That is possible. A proton in the nucleus decays emitting an electron. That is also possible. Both are possible. So how will you decide which one? That's because there is beta minus decay and beta plus decay. So in beta minus decay, what happens? A neutron decays, okay, into a proton and an electron. Now if it was beta plus decay, it would have been a proton. So it is option C. Okay. Singer, for this question, there is no easy trick. It's the easiest question. It's a simple question. But for other questions, for mathematical questions, I will do a video, say, with shortcuts. Hopefully, before your exam, I will do it. Okay. Just give me some time, I'll do it. But for that, I need your support. Please go like and subscribe. Only then I can keep sharing content. Yes, it's C. Yes, it is C. Okay, next one. A radioactive element has a half-life of, okay, this is not there is what people say. So let's move on to the next question. Yeah. Yes, for mathematical, I will do it singer. I like your name, your YouTube name. Oh, you're a singer and a techie as well. Wonderful. Okay. A hydrogen atom in ground state absorbs 10.2 electron volts of energy. The orbital angular momentum of the electron is increased by how much? Okay, let's see by how much. So E is 10.2 EV. So EV, first thing I can do, convert it because here the unit is joules per second. So this is 1.6 into 10 raised to minus 19. Okay. So 10 into 1.6. Now what else should we do? The angular momentum. So another formula of the chapter, angular momentum, del L is h by 2 pi. H by 2 pi. H is Planck's constant. How much is your Planck's constant? 6.6 into 10 raised to minus 34 divided by 2 into 3.14. How much is it? 1.6 by 2 will be 3 into 2, 6. 6 by 6 will be 1. 1.05. 1.05, and I put the power as it is 10 raised to minus 34 joules second. So where is that? Yeah, it is option A. Okay. So you might be wondering why I did this. You actually don't have to do that. So EV is just converted into joule second. Okay? Is this fine? Yeah? If it's fine, can you all put some thumbs up in the chat? Yes, it's A. Shahid. Yes, quickly some thumbs up in the chat so we can move on to the next question. Okay. The end product of decay of thorium and Pb is this much. Okay, sorry. The end product of TH is Pb. The number of alpha and beta particles emitted. This is a very nice question. I like this question. So let's say the end product is Pb. Pb is 82 and 208. Okay. And the beginning, the parent that initiated all this is thorium, 232 and 90. So let's see how much the atomic number changed. So the change in, not atomic number, the change in mass. The change in mass or the change in mass number is 232 minus 208. How much is that? It's 24. But in every alpha, there is 4 neutrons and protons together. The total mass number is 4. So every time an alpha is removed, there are 4 particles being removed. So change in mass by alpha will be 24 by 4, which is 6 alpha particles. Now let's look at the change in atomic number. Change in atomic number is how much? Is 90 minus 82, which is 8. Change in atomic number is 8 and alpha itself is 6. Something missing here. So every time an alpha is emitted, there are 2 protons emitted. So shouldn't there be 12 protons emitted, but there are only 8 protons in the nucleus? So what happens? So alpha has 2 protons emitted. So this is basically 6 into 2, 12 particles. So that means there has to be some protons being generated inside the nucleus. And how are protons generated? By beta decay. So amount of beta decay will be how much? 12 minus 8, which is 4. So there are 6 particles of alpha and 4 particles of beta. Only then it will be balanced because you need total 12. So 4 beta emissions will generate 4 protons. And that is what you can use here. So what would the answer be? It would be 6 and 4. Alpha would be 6, beta would be 4. Are you all getting it? Can you quickly let me know? Okay. 6 and 4. There are 6 alpha particles. But 6 alpha particles were taken how many protons? 6 into 2, 12 protons. But 12 protons are not there in the nucleus. So it has to have 4 beta emissions as well for the 4 protons. You will not get 45 plus if you watch this video alone. This video alone will give you 4 to 6 marks because from this chapter you will get 4 to 6 questions. If you watch the whole series, you will definitely get 45 plus. Okay. Yes. Nothing comes easy in life, students. You have to work. Okay. So we are all here to help you. You have to put in some effort. Now, the energy equivalent to a substance of mass 1 gram is. Okay. So what is the energy formula? E is equal to mc square is the formula for energy. Now we know we have to calculate for 1 gram. So 1 gram is 0.001 kilograms. That is given to you in the question. That is the mass. So let's find out the energy. E is equal to 0.001 kilograms into C is how much? 3 into 10 raised to 8 square. Oh, my battery is running low. Let me connect my charger, students. Just a second. Yeah, perfect. So E is equal to 0.001 into 3 into 10 raised to 8 square, which is 9 into 10 raised to 16 into 0.001 will be 9 into 10 raised to 13 joules, which is option B. Okay? Option D. It's not 9 into 10 raised to 16. See, this is basically a shortcut for this is just 3 square is 9. 9 into 10 raised to 16. 10 raised to 16 by 1000. 0.001 is 1000. 10 raised to 16 by 1000. So what happens? 4 zeros cancel. 13. Yeah? Shortcut. Okay. So 0.001 is by 1000. Yes, singer, it's B. Shashank, I believe I pronounced your name properly. Otherwise, I'm sorry. Shashank, it's B. Can you try once again? Okay, students, good. If you're still with me, good job. Let's look at the next question. The total energy of a revolving electron in the second orbit of hydrogen is second orbit. Important information, second orbit. Let's take the main formula. Minus 13.6 eV by n square. N square is 2 square, second orbit. So it's going to be 4. Simple substitution. E is equal to minus 13.6 by 4. Quickly solve it, students. Find out the answer. So, see, you know it's 12. 12 by 4 is 3. So, 13.6 should be something related to 3. The only option related to 3 is 3.4. That's a shortcut you can use. Okay. It's a shortcut I found out just now. So, 13.6. Round it off. 13 is close to 12. 12 by 4, 3. The only option is 3.4. So, obviously that is going to be the answer. 3.4 eV. So total energy of an electron revolving in the second orbit of hydrogen is minus 3.4 eV. C. Okay. Is that clear? So these are C. Yes, Shashank, it's C. So these are some questions that I've taken from past year papers. So there are some questions from half-life as well. Those came in last year papers. But some of you were saying half-life is not there. So I have to get back. I have to check that properly. So you can, if that's not there, then you don't have to go through that. Otherwise, you can go through that. But, this is a video that will be forever in YouTube. So if in the next year it's there, students should be able to use it, right? That's why we're solving all past year papers. Alright? So I hope you all understood everything till now. Okay? Thank you for staying with me till now. And if you know the formulas, you will definitely score 4 to 6 marks. Okay? So I will come back with more videos on different chapters. If you have any doubts, you can just ask me in the chat. Otherwise, we will wind up the session. Do you have any doubts, students? Okay? And some of you might feel I'm slow, so you don't have to watch the live. You can go watch the recorded. You can put it in speed 2x and watch the live. Because I'm doing all the steps because I don't know about the crowd that I'm addressing. So it's for a huge crowd. So some people might want all the steps. So I'm just making it a fair trade, doing all the steps. So that's why it's taking time. I hope you'll understand and be considerate. So thank you all. Thank you for watching. If you have any doubts, you can ask me in the chat. Otherwise, you can all leave. Okay, bye-bye. I'll see you all next week. I'll just wait for a minute and see if there are any doubts in the chat. Anything you want to ask, students? So you can also let me in the comments, okay? Let me know in the comments how the session was so I can keep improving, and let me know what all you need so I can pick content based on that, okay? So let me know in the comments and give me like the video, subscribe, share this to your friends so they also become helpful. Let's all learn together, okay? So make sure at least 3 or 4 of your friends are also learning with you, okay? Because, together it's more beautiful than if it's alone. Anushka, welcome Anushka. No doubts? Okay, if there's no thing, then let's wind up. I'll see you all in the next class. Bye bye.